Hi, Chris.
Hey, Arnaud. Where did we leave off?
I think we had this.
I think we realized that while blockchain is a lot of fun, the real money lies in selling pets, right?
Yes, I think that was the plan. So we started with applying to this MVP for a pet store.
Yeah, so
and we had this scaffolding for servant.
Yeah, so we wrote the little REST app that with servant, but we still wanted to do the same thing that we did in the blockchain app to integrate the extensible effects thing with the free or simple library, right?
Yes.
Yeah. Okay. So let's look. Okay. Here we have this main thing that starts our server, and then we have some server code. We have tests.
Yeah, we have this.
I
think they failed, right?
Yeah, I think I still have it running here.
Oh yeah.
Okay.
Yeah, it's failed.
So I expected a pet, got nothing. Let's look at the test. Okay.
Yeah, we sometimes need tests.
Yeah. Okay. And add pet. That was like behind the server. That was our business logic route.
Yeah, we were just testing the business.
Our handler. So we give this handler a pet, and then the result. Oh yeah, we wanted the add pet to return all the pets in the store.
Yeah.
So something's not working because there's no pet in the store in the test, right?
Okay.
Okay. So let's look at the code. Okay. Start server. That was what we were calling in main.
Yeah, we had the application scaffolding.
Yeah, so we do run from servant or from warp, and then we port 1, 2, 3, 4. Application serves a bunch of routes, and the routes are okay. We only have the add pet route right now, right?
Let's keep it simple.
And it's like okay, pets takes a pet as JSON and returns the list of pets. Okay, cool.
Perfect.
And and here we have the handlers. We already put this in because we'll need later some mapping for the F stuff. We'll get back to that. Okay.
And we have this ID because we are going from the same.
Oh yeah.
It's type, right? There is
right now it's identity because the handlers are already servant handlers, but we'll change it to F handlers, and then we need to map between the F world and the servant world, right? Okay, we'll get there.
I think I can spot why it's not working.
Yeah. So add pet the handler and here. Oh yeah, sure.
That is easy.
Empty list. Okay. Should we just for now just return the pet here?
Yeah. Let's make.
Okay. Let's see.
Pass.
And GHC ID already. GHC ID is so fast.
Is the application working? Scaffolding of the server. Maybe.
Well, let's. I think it forgets stuff. Let's test that. Okay. Let's see. So let's add another pet.
Yes.
What? So we have test pet 1 and test pet 2, and we add test pet 1, and then we add test pet 2 as well.
Yeah.
And then obviously the result should be test pet 1 and test pet 2. Okay, let's see. What does the... Okay. Yeah, that did apparently forget test pet 1. So let's make that work.
Yes.
But should we be...
I think before that we said that we might want already to integrate the effect stack into
let's port the plain servant stuff over to use extensible effects. So I think we already have the imports here for the free or simple package. So F and member and interpret and all the stuff that we'll need. Okay, where do we start?
Let's do top down.
Yes. So
the first thing we need to do is to get back. So we have this nice word of effects where we are composing effects with each other, and we have this kind of ugly REST word where we are basically doing a lot of I/O.
Yeah, should we first rewrite the add pet route in terms of effects and then adapt the mapper?
Exposing the business effect that we want to run.
Yeah, so now it's not just M, but it's F.
Yes.
So now and this is a monad, and right now we don't need anything. Well, I guess we'll eventually need the pet store effect, right?
So maybe we can just make it manifest right now.
Yeah, pet store effect. Then we'll write that one.
It should be a member.
Oh yeah, right.
Because now we want to say that.
Yeah, that's how you tell F that M like the effect stack that's still after this effect has been applied, or that the effect stack basically needs a pet store effect to work, right? And effects are kind of like modules, right?
They're kind of.
So this is the module that supports our business logic, basically. Okay, cool.
That probably doesn't compile, right?
Yeah, I mean, we don't have a pet store effect, so this will just say, constructor.
Let's let's build it maybe. Let's
yeah.
define it.
Yeah, sure. So what was it? Pets effects in F are GADTs, right?
Yes. So that's plain data types.
So and I think
not that plain.
Yeah, we have the language extensions already here. Okay, cool.
Yeah.
So data pet
not too many extensions for the Haskell app.
Yeah. Okay, so pet store effect, and we want to model one operation.
Yes, which
and
is adding a pet.
Yeah, it's like we do that as a constructor, and we add a pet, and we want to return a list of pets, right?
Yes.
And this is where we need the GADTs, because we don't only want to capture like the values that are passed as a constructor, but we also want this phantom type return type here. So this is kind of like a function declaration, right? Like just the signature.
It looks. Oh, you forgot the type, the return type. So the type constructor.
I always do. So this needs to be a pet store effect to work.
Yes.
Okay, cool.
Let's
see.
What is the link between the two add pets? So we have a capital A add pet and we have a lowercase a.
Oh, yeah, sure. We need to use it here, obviously.
Yeah.
So I guess this. So instead of just doing the stuff right here, we'll just basically send this effect, operator, and then.
So the basic idea is that we have those GADTs that represent effects, which are really values, basically just values with some type annotation, and then the send operator injects that, lifts that into the effect monad.
Yeah. So we send this out, and I'll keep the code the implementation around here in a comment because we'll later need to interpret it. And
well, the code is rather simple, so probably we could. Remember it, but that's fine.
Okay. Yeah. And it says, okay, there's some type error in the handlers where add pet.
Yeah, because now we have handlers, but
find elem, that's from F, right? And it doesn't find the pet store effect.
Well, which is fine because now there is no way for servants to know that how to handle our handlers.
Right, because the handlers are like in F world now, right?
And we need to.
And we need, instead of identity here, we need this, we need to go from F world to servant world, right? So let's do F to servant.
Yep.
And what's the type of this? It goes from F and some stuff here to a servant handler of X. And that's also X. And now we need our effect stack here, right?
Yeah.
I mean, we definitely need our pet store effect.
Yeah.
And then
so if I remember correctly, servant needs two things. It needs a way to handle errors that are servant errors.
Yeah, I think we can just use the F error monad that we already have there, the error effect. Yeah. Error of a servant error.
And well, we need IO.
Yeah. Okay, so I mean that's usually how the effect stack ends, something like that, right?
Yeah.
And then in order to make F to servant work, I think it makes sense to break it down into two steps. We go from the F world into the just standard Haskell IO world, and then from the Haskell IO world into the servant world, yeah? So we'll just do F to IO. And then after that we do IO to servant.
Yeah.
Cool. And F to IO will just be, we go from this thing to IO off.
So that's where we need some kind of error handling. So that will be the either. So
because that's what servant expects later as well, right?
Servant expects some either value with
error
either a servant error or some result.
X.
Yep.
Okay, looks good. And then let's just make it undefined for now, just to see if it compiles. Okay. And IO to servant would be then this stuff.
Yeah, this is
going to
pretty standard
to a servant handler, right? And
no, it's IO to servant.
Oh yeah. And I think here we can just put it in place because
this one is pretty much boilerplate.
Yeah, because handler from the handler constructor from servant already gives us a handler, but it expects an either T.
It expects the next.
Oh, except T,
which
I guess
from the IO.
And I guess from this we can just easily go to an except T by doing except T.
Yeah.
Okay, cool. So this is how we get to servant world. Let's see if it compiles.
Sure. If it compiles, it should work. Well, yeah, we have something like a pet, which is we don't need. Let's go point free.
Yeah. Of course, this one takes a pet already, so we need to pass it or we need to go point free. Okay.
No need to.
So this works out well. Let's see.
And okay.
Of course, our tests are still expecting the IO monad.
Of course.
And this is now F. Okay,
Well,
so I mean, let's just put the
let's fix the test. We can do. We can basically use the same.
We just want to. The tests operate in IO, right? So let's take the F to IO part. Yeah. Okay. So I guess this is all the F monad. So we'll just do F to IO. Yeah. Let's see.
You didn't. Oh yeah, and we return an error.
Now we do error handling. So the type changed as well. So we have an either, not just a list of pets.
Yeah.
Okay, that should be right. I mean, hopefully this works. Undefined. Oh yeah, because we put
the
it.
effect is undefined. Okay, let's define it. That's easy enough.
Undefined. Okay, so now we need to go from the F world to IO, and I think first we need to handle our pet store effect.
Yeah. So the way to do it is basically that we're only composing functions. Basically, that's really the cool stuff with effects. Well,
yeah, and they
generally with Haskell, of course.
And they just one by one like take one thing off the stack, right? Like,
so,
and when they take something off the stack, they can use whatever is left on the stack to implement that.
In this case, we need 3 handlers. One that will handle the pet store effect.
Yeah, we need run pet store first, and then we need run error, which comes from F itself, from the library. We're importing that somewhere
that
here.
we take care of the whatever error we can throw.
And then run M, which takes care of IO, right? We're getting that from freer as well. Yeah, okay.
Okay.
So let's see.
Probably doesn't compile. Yeah.
No, because we didn't define the run pet store. Okay.
Let's do it.
Let's do it. And let's do it down here.
Yeah, for example.
I mean, we should probably break that up into separate files later, but...
Yeah, but it fits the screen, so that's fine for the moment. And yeah, besides, it's just an
Okay, so run pet store, what will it do? It will go from an F that has a pet store effect in its... Actually, it goes really from this.
Yeah, let's write it simply like this.
Yeah, it goes from this.
And we peel one layer of the onion.
We peel off the pet store effect.
Yes, and we need to have an F.
Oh, yeah.
Let's do undefined for the moment. And, well, we can probably abstract some stuff here, because basically we don't care for the pet store effect whether or not there are other effects besides the pet store effect.
Yeah, we can just abstract over what's left on the stack, right? So we can actually later chain it however we want. Okay, cool. So type level list, there's some remaining effect stack here.
Yeah. And so we are really expressing the fact that our handler, our function, consumes one layer of the effect stack and leaves the rest untouched. That's cool.
Yeah, it's nice because this is like not entangled with the rest of the effect stuff right now. It really just expresses the direct dependencies, right?
Separation concerns.
Nice. Okay, and now, so wait, how does it work? In order to handle this effect, which is this pet store effect, we can this function, right?
Yeah. Interpret.
So
what we are really, because in the end, this is all just values and basic.
Yeah,
this is the main kind of language that we're defining, which is the language of our business effect, or our pet store effect. So we are going to interpret that language, and well.
So I mean, we need to handle.
Language now, but
I mean, right now we only have one operation in our language, which is add pet, and we need to handle this here. So we write one interpreter for.
Yeah.
Okay. So let's eval. So we're defining eval here as something that handles the different operations we have. Add pet equals, or just for now.
Yeah,
do this.
Remember how we did it before the free or simple package? It was much more involved because we have to do this handle relay thing where we have to handle the fact that whether or not we were in the effect, that was a bit more cumbersome.
Free or simple is really like the third generation of extensible effect libraries, right?
It really simplifies things a lot. So now we really only want to say, okay, we are going to interpret that effect.
I mean, as a first thing, we just return the list of pets.
Yeah.
So let's see if this compiles.
No. Oh, yeah. We need to annotate the eval function because now it's not exactly.
Yeah, let's help the type inferencer a little bit. Yeah.
But,
so we go from a pet store effect.
Yes.
to something that's, again, using effects somehow. I mean, it's not using any specified effects right now, but we'll need to get back into the effect monad.
Let's call it N.
Yeah, let's give it a
different A, not X.
Oh yeah, A. Let's give it just different names than the ones up here, so you see that there are different types, right? Okay. That it?
I think it is.
Let's see. Yeah. Oh yeah. Sure. Now we're back to the failing test, but at least we're in effect world now.
Yeah.
Okay, that's good. So let's fix it. Okay. So it forgot the first pet. So I guess we need some kind of memory. Some kind of remembering.
Some kind of storage. Well, basically, if we are running a pet store, we would like probably, if we add pets, that they are persistent, kind of, right?
Sounds reasonable.
We might imagine that our server might crash.
Okay, let's summon a database.
Yeah.
Okay.
Yeah, so, and yeah, we'll do it that.
Well,
as
I'll
an
make a
effect.
database effect. Okay,
Yeah, of
cool.
That's pretty. Yeah.
Data.
So easy to program. with Haskell.
Database effect A, where should we just store some byte strings?
Oh, wait a minute. Maybe we can. Let's take a step back.
Okay.
How would we use
yeah.
that effect?
That's exactly. Let's start with how we use it first, rather than
maybe that might,
getting
that
ahead of
might give
myself.
us hints on how it will define. So we get that add pet, and so we want to store the pet in the storage.
And let's store byte strings.
Yeah, let's store byte.
So we do, and it's I don't know. Should we call them a document?
Yeah.
We add a document which is the encoded pet.
Yeah, probably use something like MongoDB. That rocks.
Yeah, totally.
Yeah. Awesome.
Want to be web scale?
Yeah. No, we could be. Yeah.
So
Worldwide scale. Yeah.
so we add the document. We add a
Favorite
pet.
free. Okay, so we add a document, and we need to return the state.
Oh
of the
yeah.
store.
So let's say list documents.
Well, that becomes interesting. Because now we have actually two effects.
Oh yeah. Database.
Well,
the database needs
effects,
two.
but
Yeah.
Two verbs.
Yeah. Two operations in our effect.
Operation in our effect. Yes. So we are really separating because we can imagine that. We might have different ways of adding and values.
And list document.
But list documents is list of byte strings probably.
Yeah.
Not
Oh,
something-
what's this down here? Oh, look, that's convenient.
Wow.
Decode pets. Oh, okay, awesome.
That's fine. Yeah, awesome.
Nice. So we just decode the pets, right?
Yeah. No, Haskell is magic. Really.
Yeah, I know.
Functions appear from the blue. That's just awesome.
Cool. So okay, we need two operations. We need add document.
Yep. Fair enough.
And we need list documents. And
so add document will take byte string.
Yes, add document goes from a byte string to
database effect of nothing.
Unit.
Yeah, unit exactly.
And list documents just goes to database effect list of byte strings.
Mm-hmm. So that's where we see that DHTs come into play, right? But we are really expressing the fact what is our effect, what is our verb in our effect.
Yeah.
Actually
so
producing.
Let's do add document with a database effect.
It's kind of boilerplate, right? Maybe we could find a way to generate that, but.
Yeah, or I kind of like actually instead of defining these separate functions to just put it here, because then it really shows you in the effect handler like, this is sending out to another effect. It's kind of just passing like a message.
It's really exposing the fact that we are at some layer in our system, the layer of the effects and the app, what we call maybe layer 1 or layer 2, something like that. I don't remember that names, but numbers.
Think
we
so.
Don't need the
you need these like composition, because list documents doesn't take any arguments.
List
right?
documents.
Oh, list
There might be several
documents. Yes.
And same in the function name.
Here. And now, I mean, obviously, the effect goes into our effect stack.
Yep.
Actually, let's look at what happens.
Yeah, let's look at
when we don't
what
do this yet.
JCID is telling us.
Byte strings. Let's see. Oh, I think I put a pet into the data store somewhere. Yeah, this is a byte string.
It should be.
And this is a list of byte strings. Okay.
Of course, yeah. Copy pasting,
Yeah.
But we have a type checker.
And now there's some either stuff.
Error handlings again.
Because we're saying that we're going from an X to an X, but in fact this returns an either of string or something.
Yeah, that's what the signature says, because it needs to handle errors. We might fail to decode things, and I think we might also imagine that our database fails.
Oh, right. So let's just
Maybe
model our database effect in a way that it actually allows for failures. So I guess let's start with just the list document route for now. So let's just say either, well, let's switch to protolute or something later. Let's just do string for now.
Yeah.
Okay, so either string or byte string. And then send list, does it,
Yeah,
oh, I need to,
the return types are not
obviously I need to
anymore.
adapt the type here too.
Yeah, that's where some generation stuff.
Yeah, or I mean, if you just inline this, then you don't.
Yeah, inlining. Yeah, well, I know you're a big fan of that. Yes. Okay. And then, well, the return type of @pet needs to be.
So now this is an either. It's not just.
Yes.
And then this is an either.
That becomes interesting because we don't really want our @pet function to return.
Yeah, so instead of like passing the either along, we can just take the error case and throw it into an effect, right?
Yeah.
Like let an effect handle the error case.
Yeah, because we have the error handling effect in our stack.
So let's see. So this is a list of pets.
Yes.
But it's an either of a list. So case pets of right pets. In this case, fine, we'll just return the pets. Or it's a left with an error code.
Maybe you can just let undefined for the moment.
Sure.
We don't have tests for the error case anyway.
Yeah, okay.
And probably we'll have some name shadowing here, which might not be clean. So it should be
pets. Oh, let's make it something like
list,
pets prime or something.
Well, yeah, fair enough.
Sure.
Okay, how does it look like?
Oh, of course.
Yeah,
of course.
Now we're depending on the database.
We're trying to use the database effect, but the function doesn't say that it has a database effect. So we'll need to tell it, okay, so in our effect stack, somewhere further along, we'll have a database effect.
Which is really a way to express our dependencies very explicitly.
Yeah, and it's nice that we don't have to like put it somewhere in an exact place sequentially in a list here. We can just say, oh, it's somewhere in there.
Remember M?
Yes.
And we probably need to add it to the eval. Because we don't have the same in the eval function here.
You're right.
You know what? We might want to use those extensions like scope type variables and ranking types.
But, it will save us some typing here.
Yes, at the expense of long list of extensions.
So let's see. Database effect is not a member of the type level list errors, servant error and IO in run pet store. Oh, sure, because we don't have a handler for the database effect yet.
Okay.
So we'll need to write one. Okay. So run database. Should we just to get something working with the tests, do an in-memory one?
You don't want to spin up a MongoDB server? No. Okay.
Okay.
Well, fair enough. Let's not do that.
Okay. In-memory database. Cool. And
let's show it into some mvar thing.
Yeah. Let's just do mvar for now. So let's define a database, which is a database which has a list of documents.
Yep. And just list of byte strings.
And let's initialize one. So we have the db mvar, which is a new mvar database, which is an empty list.
And we need to pass that to our handler.
Yeah, so because the handler will need to access the database and update it, right?
So so we need to pass it to F2 servant somewhere.
Right. So we need to do this and this and say here that, here, right?
Yep.
That now
mvar
database.
Yep. And we need
I guess you need some kind of mutation of something because the app keeps running and you want to keep it around, right?
Yeah. It's hard to avoid side effects.
Completely,
if you want to have to do something in the world, and we need to pass it to F2 servant too.
Do we?
Yeah, because otherwise the top level function is.
Oh yeah, you're totally right. We have to put it to.
So yeah, slightly cumbersome, but we could refine that later on.
Yeah, totally.
Yeah, I've seen cool stuff yesterday at this conference, in Boulder. It was very cool, but those layers and this.
Okay. Now what we're missing.
Did it work?
Run in memory database, of course.
Define it.
Oh, and we didn't tell it yet that we actually now have a database effect handler in our.
Probably not before the pet store. It's
you're right. The pet store.
That's where we are really telling the system the order of effects that will be handled.
Right. So the handlers just say.
We need
the handlers just say what they need, right?
Yeah.
But then eventually we'll need to provide a linearization, basically where everything is like comes before the things it depends on. Okay. So database effect, run in memory database.
Maybe we can try the undefined trick. I'll just to make sure that things are compiling.
Yeah, let's start with the run in memory database, and
we need to pass.
We'll probably okay. Let's get rid of this.
Yeah, and we need to pass the mvar.
We process the database effect, and we're passing the mvar, of database. And then, but undefined?
Yeah. Let's try that.
I think we repeated our type somewhere. Yeah, we have this effect. I guess we could just remove the type signature here and let it be inferred, huh?
Yeah.
Okay.
For the sake of clarity.
Or put it to an alias, but.
Yeah, that's fine.
Okay, so. What's happening?
This is a test. Yeah, of course, because now we need a store.
Oh, sure.
In our test.
Okay. Because F2IO now needs a db mvar, right?
Yeah.
We have the code somewhere here, right? So in the beginning of our test, we just create a db mvar.
Yeah.
Let's see. Okay, undefined, yeah. We left something undefined. I love how fast GHCID is.
Yeah, it's awesome. Honestly,
yeah. It confused me in the beginning because it was done before I switched tabs.
Yeah, it's really hard. Yeah, and the fact that it can run the test. I mean, it's not only compiling.
Oh, yeah. Just gotta call the test function.
Okay, so let's do the same.
Run in memory database. Okay, so what do? We interpret.
Yeah.
And we define our eval.
Okay.
Where eval handles the add document of a document. And it also handles the list document of, that's just this. And in case of, in case of,
so what are we going to do with our document? Well, the simple thing that we can do is basically we get some byte string and show it in our list.
Okay, so modify the mvar?
Yeah, we need to modify our mvar. Simple enough.
db mvar, and then we provide the function that takes the actual database and goes to, I think we have to return a tuple where there is the updated database.
Yes.
And whatever we want to return, but that's just unit here, right?
Yeah.
Because add document
doesn't have.
Just have unit. Okay, cool. So and then to produce the updated database, we just do db. It's a record, right? So we just do documents equals document with we just put it at the beginning of the list
of db.
Right. That's the accessor. Yeah.
Yeah. You could do some destructuring here, but it's fine.
And list documents.
Or use lenses.
Yeah. And list document does what? It just does.
It just read the mvar. It just read the documents field inside the mvar.
Right. Read mvar of db mvar.
And we can fmap the documents.
Yeah. Documents. Okay. Let's see what happens. Let's see.
This rigid column type variable thing.
Yeah, sometimes the type errors are a little bit hairy.
So maybe we probably forgot to give a type to eval.
Oh yeah.
That's probably
again, right?
Yeah, again.
See every time. Okay.
It needs to be database effect.
Yes.
And we can remove the constraint because otherwise we
true.
some troubles.
Yeah,
Okay.
we can't make the database effect depend on the database effect.
Oh, interesting. Oh, okay. Yeah, of course.
Sure.
Modified var is in IO.
Yeah, it's in IO, it's not in F.
So let's send in IO.
Yeah, it's like lifting, right? It's like you basically, okay, we turn the IO monad into like an IO effect
Just send it.
by sending it.
We need to do it for.
Yeah, I think we need to do both cases, right?
Yeah.
Okay, send it.
Yeah, because now our list documents can fail, and so we need to return an either.
Right, we made an interface for the database with our effect that has failures, but the in-memory one just always.
Yeah,
it doesn't have a failure. That's just produce a write always.
Yeah.
Okay.
Simple enough.
So write. You know, we can test failing later.
Dot.
What?
Dot.
Yeah, that's better.
Oh. What that?
Now it says, hey, you actually need I/O to be part of your effect stack.
But yeah, of course, yes. Because we are doing IO, so there is no way.
So we need to tell it, hey, there's a member I/O in our effect stack.
Yeah.
Oh, it's N.
And we need to tell it at the other level, at the
Yeah, we
top
need to tell it up here as well.
for M. Yeah. Okay.
Yes. Okay. Let's see. Oh, fine. Well, it compiled and ran. It's just the wrong order. Maybe we should have used a set instead of a list in our.
Yeah. You know what?
Should we just make the tests pass?
Yeah.
Okay. Okay. Cool. Wow.
Wow.
Wonderful.
Green bar. Awesome.
But now, I mean, I don't want to invoke MongoDB yet. But I kind of want to know what our business logic does if the database does fail.
I think that we can actually write test for that.
Okay.
And you know what? Because we can switch on and off the interpreter of the effect, we can basically write a pet store effect that relies on the database effect that shows an error.
You mean a handler for the?
Yeah.
Yeah. Okay. So far in our test, we just used the effect stack from our production system, right?
Yes.
Let's make a second test that says we test add pet with failing database.
Yeah.
And so now we
don't need the mvar database because.
yes. So let's see. So let's take the effect handlers from our production system. Put them in our tests, and we replace the database handler with one that is a failing database that always fails. So we basically mock it out, right?
We can remove the parameter.
Yeah, we don't need an mvar database anymore.
And we probably need to rename the effect to IO, something like failing database effect or handler or
Run failing database?
No, the effect to IO, this function. Otherwise, we'll have some name conflict.
With failing DB.
Yeah.
And now we'll handle this down here with the effect stack that has a failing DB in there, right?
You can remove the DB
we don't need this anymore.
Maybe we don't care about how many pets we add. A single pet would be enough, so we can just remove.
Sure, let's keep it simple.
And now what we expect some kind of error coming from our pet. So maybe something like.
Should we leave the test like this for now?
Okay, yeah. Let's have a failing test.
Write a test that we have a test that pretends everything should be working, but obviously this test should fail if everything goes right. Does that make sense? Yeah. Okay.
Looks like a double negation.
Okay. we still need to implement the failing database handler. So I guess this is very similar to our data run in memory database handler, right?
Yeah, because we can probably make it shorter.
Yeah, because it does. I mean, because it doesn't need an mvar.
It doesn't need IO.
Yeah, let's implement it. We'll see, right? So it will just.
And we don't need to eval everything. We can just have a partial case. We don't care. We are in test. So if we have a partial match failure, then that's fine. We know that we. So maybe just inline the eval for the only case, because the only case that can fail is a list document.
Don't we get a like an unexhaustive pattern match warning then?
But maybe we don't care.
But no, I think we do, because we do add a pet down here, right? So this case needs to do something, needs to succeed. Let's keep it like this. Let's just do let's just do pure unit here.
Yeah.
Because I mean, sure we can add the pet, but since the database is failing later anyways.
So we don't really need to interpret add document.
Okay, I mean I think that doesn't work, but we'll see. And then list, we had only implemented error handling for
list
or error reporting for list documents. So let's do something that just does a pure of left.
Yeah, and some error string.
And I think that at the store level,
This is a string.
we did a string, yeah. Okay, so at the store level we did a left of db failed. Okay.
Yeah.
At the database level, okay.
What is the compiler telling us?
It's probably telling us something about flexible contexts. Okay, let's just add this language extension. Not in scope run, failing database. Did I mistype something here? Oh yeah. It's supposed to be this.
Yeah.
And yeah, we're not using IO now, so let's just get rid of the IO effect.
And we can get rid of flexible context because that's what.
That's why it's needed.
That's why
okay.
it's needed. Yeah.
Okay, cool. Pattern match not exhaustive. Patterns not matched add document.
Okay, fair enough. I was going to suggest to remove the warning, but
Nah, I think this works.
no.
Well, that's not because there's something in the test. I think it's our main code there. We still had an undefined there somewhere. Yeah?
You sure?
I think so. Remember? Like it doesn't say here undefined, prelude.undefined.
So we should have it defined somewhere. Yeah.
Undefined. Let's see. There we go.
Oh yeah, we don't handle the failure, of course.
Oh yeah.
I'll see, Arnaud.
So okay. So
what do we do?
Yeah, sure. We just did undefined when the database returned an error. So let's do something with the error.
Yeah. So this is basically this is our top level handler. So why not throw an error?
Yeah. I mean, eventually, I think what we said is that we want errors to be servant errors, right?
Yeah.
We want to. I mean, at the end, we want to tell the user some kind of HTTP, whatever.
Yeah.
Let's keep it simple for the moment. Just do an error. Whoa, what did I do here? Just do an error 500.
Yeah. And it should be throw.
Throw error.
Yeah. Throw
Error, which comes from the extensible effect library as well, right?
Yeah.
Here, which then integrates with the provided error effect. Yeah. Okay.
So this probably means that we need to rely on the existence of some error handling effect.
Sure. It cannot find the element error servant error. So
which kind of breaks the whole separation of concern thingy.
yeah, maybe we should make another layer in front that is servant specific.
Actually, it would probably make sense at this stage to have our add pet function to return neither also. But maybe let's keep things simple.
Let's do servant error for now. Yeah.
Yeah, we need to ship it because our marketing team is really eager to sell that. So
we just say okay.
and you need to add it to eval too, I think.
Right. So now our run pet store can produce servant errors.
Yes.
Yeah. That's what we wanted. We wanted the test where we put a write to actually provide a servant do a servant error instead, right?
Yeah. Okay. So
here we need to make a left error 500. Is that it?
I think it is. Yeah.
Wow. Oh, wonderful!
Awesome.
It passed. So should we wrap up for the day? Should we reflect a little bit about what we did?
Yeah, I think it would be a good thing to do. So
okay,
well, we can ship the code. It will work now.
Of course.
Yeah. Well, it will work except that if the server stops, that we won't have real persistence. But that's fine.
Don't stop the server.
Okay. Okay.
So we took this application, which was just written with like regular servant handlers.
Yeah. So we have this servant handler really relies on pure I/O or the basic I/O that's the normal I/O thing that we have. So what we did was really to try to have some kind of separation content in the various layers that we have in our system. So we introduced that business effect. So modeling our business effect like our business domain, or not exactly our business domain, but more the applicative part, or is that, let's say, our services, like some
the real outside facing features that we wanted to have. Yeah.
because you can imagine that at some point, if our application becomes more complex, we will have some real core domain which will be really pure functional, right? That's the idea. That's our end goal. Here we are just starting from the outside in and molding the application, the various services that we are providing.
And we really we're able to model different concerns of our system as these separate components that kind of declare this component relies on this other component, and then we were able to swap it out. Oh, by the way, we used this mvar, right? But we could have instead. There's also a pure handler in F that allows to carry a state through in a pure way, so you don't need.
Yeah, for just in memory, we could have done that. Yes.
Yeah, I guess we could have. I mean, you need to have something mutable around somewhere, where we could have pulled it out one more.
Yeah, because once a request comes in, then you have to get the data out from nowhere, and there is no context to provide. Okay, so one thing I'm not sure about. So what are the benefits from traditional way, modular transformers, mtl-style thing?
I mean, I'm new to Haskell, so I haven't used MTL myself, right? But what I hear is that. One thing that's kind of nice is that you have to worry about order less, because if you look at this IO thing here, the IO is on the outside and the either is on the inside, and then when you work with these things, especially when there are more of them, then
so I think that there is really this problem that it's quite common when you're working with MTL style things, is you start to have some kind of multiplicative effect where if you're adding a new interface and you need to make sure that all the monads in your stack are implementing the effects, or I think there are various techniques to do that, but here it's very simple.
I mean,
we only have to expose our effects.
This is the only technique for modularization, I guess, that way that I use in Haskell, and I found it quite straightforward. You have
because you're really new to that. So
you have these interfaces basically. They say what they take and what they return, and you have different implementations for these interfaces and these different interpreters. It's just like Java interfaces but they have monads in the return types. There we go.
Okay. Well, another big thing that I really like with that approach is the test, because now we can really decouple the testing of our business layer.
Saw how quick it was to swap out our database for a failing one. What did it take? It take implement the.
Yeah, I'm pretty sure we could align the eval if we had some.
We had probably shortened this a little bit. Yeah, you're probably right.
Yeah, that would be nice if we, for future effects. Okay.
Yeah.
Let's call it a day.
Yeah, let's call it a day. And this is how we work at Symbiont every day.
Yeah, so
or some of us. It's.
We could decide.
Yes.
So thank you very much for your attention. This small play that we played for you. I'm Arnaud. Chris.
Here are these are our Twitter handles, and there is a little feedback.
Yeah. So if you want to provide maybe some structured feedback about this session, how do you feel about it?
Then we have the code here in the F in Anger repository in Symbiont.
In this repository you will find we'll find the code in various stages, and you will find the code in a more advanced stage where we actually have a real place.
So there's the branch initial version,
yes,
which is just what we started with, and then let's branch a final version after talk.
So I think we also had some time to explain the context. So we are both working at Symbiont, and surprisingly, we are working in Haskell, and guess what? We are building blockchain. Yes. And this is actually the code. Well, we are not building pet stores of the blockchain, but we are actually using F, so the extensible effects package. In our code base, so inside one of the core components of our system, and it all started last year when we were designing this whole system and this whole component, and it really so it took some time to get accustomed to it, especially for the rest of the team, which came from a more say non-Haskell background. But yeah, the greatest benefit that we have with this approach is really. We can really separate all the layers we have in our system, and when I mean layers, I mean actual operation that we are doing. Because we are doing, for example, we are doing a lot of cryptographic operations. So we are not implementing, we are relying on libraries, but cryptographic operations are really side effect operations. If you need to generate a key, then you need to get some entropy. So it's really side effect thing. And we are talking databases, we are executing some code, whatever. So it's really, what the core of our system is really about piping and wiring stuff. And that's where really you like to have that kind of effects thing.
And I found, I mean...
I think we have a question in the back.
Oh yeah, please.
What's the difference in runtime overhead compared to a typical MTL performance?
So there is a benchmark somewhere in the web, I think, which kind of old, in the sense that it's at least 1 year old. I don't know.
So it's not using the free or simple library, right? It's
using some other implementation. There is an overhead. I run some benchmarks on our application itself with everything mocked out, so no I/O, nothing. There is about an overhead of 5-10%. So only doing the piping and wiring stuff, depending on effect. On the other hand, if I suspect that if we stay that way, then this means our application is not doing anything interesting, and that would be a bit concerning. So I guess that it's always the same thing. There is no free lunch. You have to pass function, interpret stuff, and get up, down stacks, whatever. You could do it probably maybe in a simpler way. We are willing to buy to pay the price. The benefits are really very clear separation of the concern in our architecture, and so yeah, there is a price. It doesn't come free. No pun intended.
Yeah, by the way, I pushed the final code after the talk,
cool.
final version
Nice.
after talk 2018, and I think master is the same application, further evolved, right?
Master is really the full application, which actually is writing some stuff to something to a file. So we have slightly. It's basically the same thing, but
does it still
more
have
involved.
Does it still have the payment service in there as well?
Yes, and there is a payment service. So there are different effects, and there is one effect which is modeling like connecting to a payment service written in Java. Yeah, I know, and written back. And so it's just a good way, I think, to get the feeling of how it works, and how when you add more complexity to an application.
And you know, this F stuff, I found it, I mean, being new to this, I found it pretty straightforward in the sense that, okay, there's one place where you define the interface, and then there's one place where you define the implementation, or n places if you have n different implementations. And then I think we have this one additional place where we do these, where we have these wrapper functions that send out stuff, which I guess you could save if you do the sends inline. Yeah. So it's very similar overhead, yeah.
I'm a little confused. There's the thing that says member.
Yeah.
Yes.
And you said that it didn't require order, but there is a type level list which does.
Yeah, which is the final. So when you assemble all the tiny interpreters for your attacks, you are constraining the order. So that's where, but that's at the end of things. So think of like a topological ordering of a graph.
So basically the interpreters, like run in memory database or run pet store, they don't specify the order of things. They're independent of the order. You can rewire the stack as you want.
They are pure functions.
But then once you have one specific stack that is wired, that specific stack has a specific order.
But there's a partial ordering
of course.
way that you have to run
Yeah,
the effects.
of course.
What else?
Because we have that's why I'm saying this is really a linearization of a graph, or you have some dependencies and then you are traversing, and so you could have different linearizations. One cool thing that we found using that is that if you are testing or using only part of the graph, then you don't need all the effects, of course. So that's also this. Obviously, you need to get some discipline to be sure that you are not relying on everything. But
yeah, for example, one thing that we did is that we don't rely on I/O directly. We have one at the very end. We have a effect of our own, which is the only thing that relies on I/O, and everything else relies on this. So we can mock out I/O completely.
And that's really powerful because now we can model the complete system, including a network of nodes talking to each other by having our own interpretation of real world. And if you couple that with things like déjà vu, for example, which is a really great way to control and model concurrency inside the system, then you get a really powerful way of, yes, I know you're not supposed to test your application, but still, I really like to test stuff. So especially when you're going to do stuff in the outside world. So
No, don't worry, you did good.
okay. There was another no. Yeah.
So member doesn't care about the order, but I saw at some point where it looked like a pattern match on the list of effects.
Yeah.
Not in there anymore.
Wait, where on? So
We put a match on the list of people.
you mean these things?
No, in the type level list, you had a colon. You had like
Yeah, it's
some
just-
effect colon M.
It's just counting the head of a list. It's not pattern matching, it's counting a list, so you have the head and you have a tail.
Oh, right. But that does contain the order in the case, right?
Oh, it's
No,
the other
I
way.
did say that you have to be, when you are defining, so, yes, when you are defining the run Pet Store, for example, you just say, okay, the effect that I'm interpreting is this effect, and it's the first one. Because what happens behind the scene is that the machinery of the extensible effects goes through the interpreters, and in a sense, it's just this kind of object implementation done right, like it was thought initially by Alan Kay, where you're sending messages to stuff, and they're replying back, and each handler and each runner actually does that. It just gets a message and say, oh, I got a message. Can I do something with that? Oh no, pass it over to the other interpreter.
But it also happens to be pure and type safe.
Sorry?
It also happens to be pure and type safe.
Yeah, it also happens to be pure type safe and devoid of side effects.
But I think what you were getting at is that, I mean, here the run in memory database, for example, says there is a database effect at the top of my effect stack. And that is true in one particular wiring here, where in this wiring, there is a database effect at some position. So our run in memory database handler needs to also, in this particular chain of interpreters, needs to appear in this position.
It's really when you are chaining interpreters that you are really constraining the order.
But exactly, that's only when you define one particular stack that you define this order. The interpreter itself that you can have appear in multiple different stacks, it just says, oh, when I'm run, I happen to be on top in that moment, but I don't know where I am in the entire stack compared to other things.
Sure, yeah, it's a partial stuff.
And you could perfectly imagine where you are. So we only scratch the surface of things. So interpret is one way to interpret, but you can also think. You can do stuff, interesting stuff like what we did in our code. We have multiple layers of interpreters for the same effect, right? For example, we have a log effect, and this log effect is really important because it carries the sense of events that happen in our application. So we have 2 or 3 layers there is one layer which really does logging and send to whatever logger we have. But there is also a layer that say, oh, by the way, this event, I know this event, and this event is actually a way, and I can do some reporting about this event, or I can do some tracing about this event. And this is a way to have interpreters that for the same effect, and you don't consume the effect in a sense, or you can consume it depending on what you want. So you can really have the way, like,
It's like
decorators.
it's like kind of like, let's say, run in memory database, only that list documents doesn't disappear, but you have to interpret it again.
Yes.
And the first time you interpreted it, you just logged something. Oh, I did a list document call, and then next time you'd really throw it out and do
You have
whatever.
various combinators that allow you to do that concept. You can also reinterpret some effect into another effect. It's very, very, I would say, there are a lot of ways to combine things together.
I guess the most interesting parts of the things you have to learn first is, okay, there is a list of effects somehow that I'm somewhere in. There is like a way to say somewhere in my effects list this appears, and then send takes something and puts it in an effect, and interpret basically gets it out again and does something on it. And those are the basic building blocks, and then a few others to do more advanced things. But
I think we are done. If you have other questions, feel free to come to us.
yeah, thanks so much.